Hello students, today we are going to do some problems on posets. We are going to solve those problems. So the first problem that we are going to look at says, I can name it as problem 1. Now it says that you have a set S which has elements 0, 1, 2 and 3. So there is a set S which is having elements 0, 1, 2 and 3, and we have to determine that out of the relations given below, which of the following are partial ordering. So the relations that we are given are 0, 0, 2, 2 and 3, 3. One relation set is this which has ordered pairs. So we have basically 4 relation sets. Out of all these 4 relation sets, we have to find out which one is a partial ordering, which relations are partial ordering and which are not, and on what basis. So we will start with the first one. There are 4 relations over here. I will not write all of them all together. We will start with the first relation set, which is set A. So A says the relation set A is 0, 0, 2, 2 and 3, 3. This is the relation set. Now obviously we know that any relation set or any poset is formed on a certain set. So on which set is this relations formed? It is formed on the set having elements 0, 1, 2, 3. Now we have to find out that whether this relation which has been given to us, which is formed on set S, whether it is a poset or not, or whether it is a partially ordered set or not. How will we check that? Now let us say that I give the name R1 to the relation 0, 0, 2, 2, 3, 3. You can give any name R, R1, R2, R3. So let us assume that I give the name R1 to this relation set. Now I have to find whether it is a partially ordered set or not. For that, this relation set must meet 3 criteria. So the first criteria that we know is that it should be reflexive. So is it a reflexive relation or not? Now for reflexive, you know that for all A that belongs to set A, an ordered pair A comma A must belong to the relation set. This is the criteria for a reflexive relation. So now let us see whether this ordered pair belongs to this relation R1 or not. Now which all are the elements of S? 0, 1, 2, 3. So as per the criteria, we must have a pairing 0, 0. We have it here. Then we must have a pairing 1, 1 also, because we are saying for all elements, for all A that belong to S, the ordered pair A comma A must belong to the relation. Now one ordered pair 1 comma 1 is missing here. Then 2 we have 2, 2, we have 3, 3. But there is one ordered pair which is missing, that is for 1. 1, 1 is missing here. So I will say that this relation is not reflexive. Second criteria is the antisymmetry. Now we have to check whether it is antisymmetric or not. Now again for antisymmetry, I say for all A, B that belong to set A, if the ordered pair A, B belongs to relation R, then the ordered pair B, A belongs to relation R if A equals to B. This is the criteria for a transitive relation. So let us see. For an antisymmetry, so 0, 0 is here, 2, 2 is here, 3, 3 is here. So the opposite of that 2, 2, 3, 3 will also exist, because if AB exists, then BA would exist only if A equals to B. So here if this is A and this is B, so A and B are equal. That means if 2, 2 is existing, the opposite of that 2, 2 is also existing, and we do not repeat elements in a set. So that means this relation is antisymmetric. So I can say that yes, it is antisymmetric. Now we will see if it is transitive or not. For transitive, what is the condition? That for all A, B, C that belong to set S, if A comma B, if the ordered pair AB belongs to relation and the ordered pair BC belongs to the relation, then the ordered pair AC must also belong to the relation. Now the condition or the criteria is that if AB and BC exist, only then. But here you can see there is no question of AB or BC. There is no AB here and no BC here. So if AB and BC are not here, so obviously we do not require even AC to exist. So in that case, by default, it is considered a transitive relation. So yes, it is transitive. It is antisymmetric, but it is not reflexive. And for a relation to be partially ordered set, it needs to be reflexive, antisymmetric and transitive. So I can say that this relation R1 is not a poset, or this relation R1 is not a partially ordered set. Now let us consider one more relation. This relation set is as follows, that R equals to, it consists of ordered pairs 0, 0, 1, 1, 2, 0, 2, 2, 2, 3 and 3, 3. So we will start with the first criteria. Now I want to find out whether this relation is a partially ordered set or not. So first of all, let's check if it is reflexive or not. Again, I know for reflexive, if the set has elements 0, 1, 2, 3, then all the ordered pairs 0, 0, 1, 1, 2, 2 and 3, 3 must exist. I have 0, 0 here, okay. I have 1, 1 here, again okay. I have 2, 2 here, fine, and I have 3, 3. So all the elements exist in this form of ordered pair. So I can say yes, it is reflexive. Then let's see if it is antisymmetric. I know to be antisymmetric, if AB exists in the relation, then BA will exist only if A equals to B. Now if I say 2, 0 is existing here but 0, 2 is not existing, that is fine. 2, 3 is existing but 3, 2 is not existing. So 2, 3 is here but 3, 2 is not here. So I can say that this is antisymmetric as well. Okay, now let's see if this relation is transitive or not. I know to be transitive if AB, if the pairing in the form AB and BC belong to the relation, then the pairing of the form AC must also belong to the relation. So let us see now. Okay, so 1, 1, 2, 0 and 2, 2. So 2, 2 and 2, 3. So this can be taken as AB and BC, because for transitive you need to have a common element B in the middle. Okay, so AB is here and this can be considered as BC. So if 2, 2 and 2, 3 exist, then 2, 3 must also exist. If AB and BC exist, then AC must exist. So A is 2 and CE 3. That means 2, 3 must exist. But 2, 3 is already written here, so we will not rewrite it. That means it is transitive also. So that way I can say, since this relation is reflexive also, antisymmetric also, and transitive also, so I can say that yes, it is a partially ordered relation. Now, or I can say that this relation is a partial order. Now let us look at one more relation set, which consists of ordered pairs 0, 0, then 0, 1, then 0, 2, then 1, 0, then 1, 1, then 1 2, 2 0, 2 2 and 3 3. So these are the ordered pairs in my relation. Now first of all I will check again. I will see if it is reflexive. So to be reflexive, all the elements from the set S must exist in the form 0 0, 1 1, 2 2 and 3 3. So I have a 0 0 here, then I have a 1 1 here, I have a 2 2 here and I have a 3 3 also here. So I can say that yes, it is reflexive. Then I will check if it is antisymmetric. Now to be antisymmetric, if AB exists, then BA must also exist. So let us see if this is 1 2 is AB, then 2 1 must exist. Is 2 1 existing? Okay, I'm sorry, to be antisymmetric, if AB exists, then BA will exist only if A equals to B. So that means the opposite of AB, BA must not exist in other words. So AB, if I say 1 2, then 2 1 is here? No, 2 1 is not here. Now, if I take this as AB 0 2, then 2 0 must exist. Yes, 2 0 is existing. Then if I take 0 1 as AB, then BA 1 0 must not exist. Yes, but 1 0 is also existing. So that means it is not antisymmetric. It is not satisfying the condition for antisymmetric. So this is not antisymmetric. Then I will check for transitivity. So I'll see if it is transitive or not. Again, for transitivity, I know if AB and BC exist, then AC must also exist. If this is AB, if 1 2 is AB and then BC would be 2 0, then 1 0 must exist. Yes, 1 0 is existing. Okay, and this is for all the pairs, not just for one pair. Okay, if I say that 0 2 and 2 0 are there, then 0 0 must exist. Yes, 0 0 is existing. If 0 2 is AB and 2 0 is BC, then 0 0 must exist, which is existing here. Then again, if I take 0 1 and 1 2, then 0 1 is AB and 1 2 is BC. In that case, 0 2 must exist. Yes, it is existing. Okay, for any other pair. So that means for all the pairs, the condition of transitivity is being satisfied here. So I can say that this relation is transitive. But this relation is not antisymmetric, and to be a poset or a partially ordered set, it must be antisymmetric as well. So this relation is reflexive and transitive, but this relation is not antisymmetric, and so I can say that this is not a partial order. Okay, so now let's move on to another relation. The last relation that I'll be talking of is having ordered pairs in the form 0 0, 1 1, 1 2, 1 3, 2 0, 2 2, 2 3, 3 0 and 3 3. So these are the ordered pairs of this relation. So again, to find out that if this relation is a partial order or not, I need to start from the starting. First of all, I'll check if it is reflexive or not. So 0 0 is here, yes. 1 1 is here, yes. 2 2 is here and 3 3 is also here. So that means I can say it is reflexive. Now let's see for if it is antisymmetric or not. Okay, for antisymmetry, what are the pairs that I have in the form of AB and ABC? 2, 0 and 0, 2. So 2, 0 is existing. 2, 0 belongs to the relationship set, but 0, 2 does not belong to the relationship set. Okay. Then 3, 0 belongs to the relationship set here, but 0, 3 does not belong to the relationship set here. Then 1, 3 belongs to the relationship set here, but 3, 1 does not belong to the relationship set here. So it is satisfying all the conditions of antisymmetry for all the ordered pairs. Hence I can say that yes, it is antisymmetric also. Now let's check for transitivity. As per transitivity, here I can see the ordered pair 1, 2 belongs to the relation, and the ordered pair 2, 0 also belongs to the relation. So if 1, 2 and 2, 0 belong to the relation, then as per the rule of transitivity, AC, that is 1, 0, must also belong to the relation. Can you see 1, 0 anywhere here? No, there is no 1, 0 ordered pair over here. So I will say that no, there is no transitivity in this relation. So this relation is reflexive. This relation is antisymmetric, but this relation is not transitive. So hence it is not a partial order. Now let us look at one more problem. This problem says, let us call it problem number 2. It says that if S is the set of all women in the world. I take a set which is the set of all women in the world, and R is the relation which is formed on this set S. R is a relation which is formed on this set S. So it is, how is it formed? It is formed such that AB belongs to the relation R, where A and B are women. Obviously, if S is a set of all women on the world and R is a relation which is formed on this set, and if R consists of ordered pair AB, then obviously AB would also be women of this world. And the condition and the criteria for forming this relation is that if A is taller than B. So the criteria for the formation of this relation is that where the women A is taller than women B. So that means how this relation will be formed: the taller woman would come first and the shorter woman would come later in the ordered pair of the relation, because the criteria for the formation of this relation is that if A is taller than B. So this is how this relation would be formed. Now again the same thing we have to find out whether it is a partial order or not. Now let us see how we will do that. Now you're clear that S is a set consisting of all the women in the world. R is a relation which is formed on this set, which says that the ordered pair AB will exist such that A is taller than B. So let us see if we can find out if this is a poset or not. So the solution for this problem is, so basically I can say that S is all women in this world, right? And R is a relationship set which consists of ordered pair AB such that A is taller than B. Now obviously since R is formed on the set S, so A is also a woman from the set S and B is also a woman from the set S, and the ordered pair is formed in such a manner that the woman A is always taller than the woman B. Now let's find out if it is a poset or not. So basically what are we trying to find? If SR is a poset or if SR is a partial ordering or not. So, okay, so first of all we will start with the reflexivity. I will find out if it is reflexive or not. In order to be reflexive, we know that for all A that belong to set S, the ordered pair AA must belong to the relation set. Now if AA belongs to the relation set, that means A is taller than A, because this is the criteria for the formation of the relation, that the first element of the ordered pair must be taller than this second element of the ordered pair, or the first woman in the ordered pair must be taller than the second woman on the ordered pair. So as per reflexivity, for all A that belong to set S, the ordered pair A comma A must exist in the relation. So if A comma A exists in the relation, this would obviously mean that A is taller than A, which is not possible. Yes. Second is the anti-symmetry. As per anti-symmetry, if AB belongs to the relationship set, then BA will belong to the relationship set only if A is equal to B. Alright. Now if AB is belonging to this relationship set, then obviously BA cannot be exist here, because AB means A is taller than B. So if I write BA, that would mean B is taller than A, which is not possible. If A is taller than B, then B cannot be taller than A. So that means the ordered pair AB and BA cannot exist together in this relationship. So hence it is satisfying the criteria for antisymmetry. So I can say that it is antisymmetric. It is not reflexive, but it is antisymmetric. Okay, then transitivity. The last criteria is of transitivity. So by now we know that this relation is not reflexive, but it is antisymmetric. Now let us check for the third condition, which is the transitivity. So I'll see if it is transitive or not. Now to be transitive, for all A, B, C that belong to set S, if the ordered pair AB belongs to the set R and the ordered pair BC belongs to the set R, then AC must also belong to the set R. Now let us see if this is possible or not. So if AB exists in the relationship set, that means if A is taller than B, and if BC exists in the relationship set, that means if B is taller than C, then I can say that obviously AC must also exist. Why? Because if A is taller than B and B is taller than C, then it is quite obvious that A would be taller than C. Therefore, if AB and BC exist, then AC would also exist. So that means yes, it is transitive. Alright, so by now I have seen that this relationship is not reflexive, but it is antisymmetric and it is transitive also. But to be a partial order or a poset, it must be reflexive also, transitive also, antisymmetric also, and transitive also, which it is not. It is antisymmetric and transitive, but it is not reflexive. Hence, I can say that this is not a partial order.